it will also be the same shape. Just like when x is 0, what will happen? Although this is 1, so what will it cut? It will cut at where? 3, right? Can you see what I'm talking about? Can you see what I'm talking about? This is where I'm worried that you will be stuck. Okay, by the way, Jiajun, can you keep the Yao Zhang's look for him? Okay, alright, okay? Now, what if this is 13 then? Then where will it cut the y-axis? 13 now. You understand what I'm talking about? Okay? Alright, now, then if you look at other graph, it will be the other way, right? Okay? Then this is reflected about the x-axis. That means this one will be y equals to negative 2x, right? Alright, now what if I have y equals to negative 3 2x? Wow, when x is 0, you will cut at negative 3. Can you see how it's the other way around? So this is what page 131, the two graphs shows you. Are we okay here? Are we okay here? Now, why did I specifically say about the intercept? Because this one is again repeated in Ax. So you must know it cuts at what? At the y-axis. Understand that? Okay? When there is nothing, for example, if it's like that, right, it will always cut at 1. But once you have another number in front, it will cut at a number. You understand that? Okay? So this is something that you have got to remember. Okay? Now, next thing that we are going to do, I'm at page 131. So these are the two graphs that you should know. Now, next, can we look at example 5? Can all look at example 5? Page 132. Using a scale of 4 cm to represent 1 unit on the x-axis and 2 cm to represent 1 unit on the y-axis, draw the graph of this for this range. Okay? Use your graph to find. I think this one is okay, right? Now, I want to specify one thing that you need to know about your presentation. Can all of you look at the board? This is the graph, right? Remember to put y equals to 2x. Remember, okay? Now, the question says, use your graph to find the value of y when x is 1.8. That means I will go and look for 1.8, right? Correct. I draw a dotted arrow up, touch the graph, then I read off this one. Alright. Now, can you look at the question on page 132, I mean the solution on page 132. If they draw at 1.8 and they read, can you see it's 3.5? Can you see the answer is 3.5? Okay. Now, part A, you will say, when x is 1.8, y is 3.5. This is how you rewrite. And this one is drawn by what? Dotted line or dotted arrow. Are we clear? Okay. When you look at part B, what did they ask? Find what? The solution of this, right? Find the solution of this. Now, remember when it's like that, right? I must add lines with red. The original one is this one, right? Alright, so I add which line? Can you tell me? Y equals to what? 4.6. Now, when you add a line, the line must be a solid line. Do you understand? Okay? That means you will add. Okay? Of course, this one is too high. Let me just clean off this. This is the part 1, right? You go and look for 4.6 over here. Okay? Then you must draw a straight line. Am I right to say that? You must draw a straight line. Then what do you write here? Y equals to 4.6. Then this point of intersection will be the solution. This one you must draw the line and label the line. Are you clear with what I'm talking about? If you read off, it's dotted arrows. If you are solving, you must add a solid line and write down the equation. Are you clear? Okay? Alright, so if you look at the answer, they draw y equals to 4.6. Now, can you tell me what's the value of x? 2.1. 2.2, right? Understand? 2.2. Okay? So you must read accordingly. Now, the other side, I've already gone through the class discussion about matching which graph to which one on page 133. Right now, that is done during the first section. Okay, the first lesson of this. Okay. Now, next I'm going on to something that is important. Gradient of a curve. And this is where you must use your ruler. Okay. Now, all of you look at this. When we have a line, so tell me first. When I'm teaching, I expect attention. Understand? What's the term now?
The step.
Huh?
Step.
What's that?
Step properties.
You are doing now.
220.
There are 4 of you, right?
Yeah.
This father told me, go.
Plug it in.
Okay. Look at the board now. I don't test them in look at the board. Let's go flower again, whatever it is. Now, do you agree that this gradient is a constant? You can see it. It's a constant right now. What if you have a curve and I have your attention here? This is where a lot of people make mistakes. Let's say I have a curve like that. Okay? I want the gradient to this curve. Alright? Oh, look at that. I want the gradient to this curve at this point. Then what do I do, right? Alright. You must put your ruler here such that it will touch only at that point up. Understand? Okay? Then you go and identify 2 points that you can read the coordinates clearly. Understand? Then you write down the coordinates, for example, something, then this one also something. Then you apply the gradient formula to find the gradient. That will be the gradient of the curve at this particular point. Now, the formula is students always draw this line, which is called the tangent wrongly. Okay, now let me tell you what is correctly and what is wrongly. Oh, look up, this is very important. You must have some technique to adjust your ruler. Okay, look up. Okay, I enlarge this part. Now, let's say it's this point. Your line only got to touch this point. Can I follow along ruler? Don't have no ruler. All spoil already. Reverse will do. Now, can you see that this side is opaque, this side is transparent? I told you you will line one with transparent, right? Okay, now what you do is that you put this at this point, and it must balance out on both sides. You understand? Okay? Such that your line when you draw, it will only touch like that. Understand? Then you go and identify 2 points. Then you find the gradient. Understand? Find the xy coordinate, and find the gradient. Okay? Now, what is called a wrong tangent? Look at I draw the same thing. Some people, right, they draw, right, this line is like that, you know? Did it even touch? Did it even touch the point? No. Who's this? If it doesn't touch the point, this is not considered a tangent. Understand? Now, another one that is wrong. This person will draw, and it goes like that. Can you tell me what's wrong? It cuts at 2 points. That's wrong. Okay? And even when it cuts at 1 point, you must make sure that it is balanced. You understand? Nicely drawn. Not like that. All of you look here. Let's say this is the point, okay? Some people will draw until it's like very touch like that. Can you see this is also wrong? Do you know what I'm talking about here? Can you see that this is the point? Do you agree that this tangent is also wrong? Can you see what I'm talking about? I'm enlarging for you so that you know what is the wrong gradient. Wrong tangent. Can you see that if I draw like that, right? This is the point wrong. Can you see what I'm talking about? That means you must put your ruler there such that you adjust, then you can see the tangent properly. That means I must put the ruler there such that it's like that, right? Correct? Okay, must adjust properly. Does it mean that it always slant this way? Can it slant the other way? Of course can. Let's say this point, then it will go this way, right? And touch, correct? Okay? Make sure it touch properly, it's balanced, and got to adjust the ruler. It doesn't cut at 2 points, and it don't cut. Understand? It's above it. Because once you draw the tangent wrongly, I won't give you the mark for video. Do you understand what I'm talking about? And you identify the points. And don't draw so short, like that only, then you identify what I also don't know. You understand? You must draw at least a sufficient length for you to get the tangent, the coordinates. Are you all clear with what I'm talking about? I'm teaching down here. Do you understand? Yes? Okay? Yeah?
The line is adjacent.
Yeah. It's not this point, right? You can see, right? So that's what I mean by when you adjust, you may think that it cuts, but actually it doesn't. A better one would be something like that, right? You get what I'm talking about? Okay, so you must adjust your ruler until it goes like that. Understand? Okay? So I repeat, hello? This point, this tangent gradient will give the gradient of the curve at this point. This point, this line, it will give you the gradient at this point. Understand? How about here, it will give you the gradient at this particular point. Understand? So a curve can have various gradients at different points. Do you understand? Okay. All of you look at the textbook now and look at page 134. Can all of you look at page 134? Okay? I don't want people to talk. I don't want people to talk. Okay, can you look at it? When a straight line touches a curve at a single point, the line is called a tangent to the curve at that point. Understand? Yes or no? Okay, now next. When you look at page 134 at the graph it will show you. Okay? The line L1 touches the curve at P. So L1 is called a tangent to the curve at P. Similarly, when a line L2 touches the curve at Q, L2 is called a tangent to the curve at Q. Are you clear? Are you clear? Okay, now next. The gradient of the curve at the point is defined as the gradient of the tangent. Repeat again. The gradient of the curve at a point is defined as the gradient of the tangent to the curve at that point. Okay? Okay? Hence, the gradient of the curve at P is equal to the gradient of line L1, and the gradient of the curve at Q is equal to the gradient of the line L2. Understand? Okay? Now, why is the gradient important? There are several reasons, but the most important one you should understand for now is that gradient tells us something about the rate of change of one variable with respect to another. Now, for example, I think one that you are more familiar with will be if I have distance time graph and this is like that, and another one is like that. This one is of a greater velocity curve. Why? Because this is steeper. Can you see? Distance time graph, the gradient will give you velocity, right? Or displacement time for the matter of fact. Alright? And then for velocity time graph, the gradient will give you what? Acceleration. So whether is it steeper or less steep, you will measure another quantity. Is that understood? Okay? Alright, good. Now, next, can you look at example 6? Because after example 6, right, we are going to do questions on the graph paper already. Okay? Can all of you look at example 6? Alright. Are we okay so far? Do you understand what I mean by gradient of a curve at a point? What must you draw? A line. What's the line called? The line is called a line. The line is called a tangent. You must draw an appropriate tangent. Understand? It must be balanced. It cannot be lopsided. It cannot cut at 1 point. Sorry, it cannot cut at 2 points. And it cannot don't cut at all. Do you understand? Okay, good. Let's have a look at example 6. The variables x and y are connected by the equation. Okay, I'm going to write down. Okay? The table below shows some values of x and the corresponding values of y. Find the value of a and of b. Now, I'm not going to go to this. A and b you will know how to find. Are we clear there? Okay, good. Now next, look at part B. Using a scale of 2 cm to 1 unit on both axes, draw the graph of this for this particular range. Okay, turn to the next page. Can you see they draw the graph and the graph looks like that? Okay, I'm going to sketch the graph here. Something like that, right? Everybody okay? I'm talking to you. Everybody okay? Now, first, I know you are tired. Let me just tell you, I'm fully tired. Not just you tired. You understand? I want you to pay attention. I didn't arrange the class timetable to be max at this particular hour. Understand? Oh, but I'm given this timing, so I will come at this time. Clear? Okay, let's have a look at the question now. Okay. What did the question say? Can all of you look at part C? Page 135, part C. By drawing a tangent, find the gradient of the curve at the point 1, 2. Now, do you agree that identify from the curve? 1, 2 is somewhere here, right? Correct, Abbas? 1, 2 is somewhere here, right? So, when you put your ruler, okay, I need the long ruler. Long ruler, long ruler. When I put the ruler, all of you look up. You will go this way and you adjust until it just cut. Understand? Understand what I'm talking about? Then you draw the line. Now, do you go like that? No. Do you go like that? That will cut at 2 places. No, you must go exactly and you must be balanced off. Understand? Okay? But I say okay, I don't want people to smile or laugh in my lesson. Because I don't think this is very laughable. If all program can laugh right, I would have laughed the whole life, you understand? Okay? It's very contradicting. Some of you are laughing, some of you are sleeping, you know. Some of you are daydreaming. Then what am I supposed to do? Still teacher. Okay. Now look at the next one. Can you see that they draw the tangent with a green line? Correct. Now, the textbook uses vertical change over horizontal change. Now, I don't want that because it will make mistake. That means after you draw the line, okay, you go and write down convenient to read points. Okay, what are the coordinates? Then you use the y2 minus y1, x2 minus x1, the formula to find the gradient. Are you all clear? And one more thing I want to warn the class. One more thing I want to warn the class. You do not choose the point itself. Do you understand? You don't choose the point itself. That means you don't choose this point and this point. Understand? You must choose one up, one down. Clear? Clear? Okay, alright, good. Now, next. Okay? Now, you don't pick this point because I don't think you should pick the point that you got. Just like when you do linear law later, you don't choose the point that you encountered. Okay? This is like sort of to balance off the wording. Okay? But even if you choose, right, it's okay now. But sometimes they draw a point for you. The point is not 1, 2. It may be 1.25, right? It's very difficult to gauge. Do you understand what I'm talking about? So it's difficult. Alright? So it's better to choose one on top, one below. That's easy to understand. Okay. Now, next. They say the gradient of the curve at the point HK is 0. Draw the tangent at the point HK. Now, where do you think the gradient will be 0? Where is gradient 0? When the line is what? Horizontal. So, it will be this point, right? The highest point, this point will be where the gradient is 0, right? Correct. Now, then they say, draw the tangent at the point HK and find the value of H and of K. Oh, look at the point there. What's the X coordinate? 2 and 2.5, right? Alright? What's the Y coordinate? You cannot get 3 1 over A1. Just read from the graph. What can you decide? 3.1, right? Just 3.1, right? Can you all see? There's no way you get 318. This whole thing is bad. Do you follow? So do you get a 3.1 here? Yes or no? Yes, huh? Okay, so this is how we go about doing the question. Are we all okay so far? Are we all okay so far? Okay, good. Now, next page. Okay, I want to test people. Oh, look at the bottom. If I have a curve like that, let's say, I want the tangent at this point. You must put the ruler over here, right? Such that you will only touch at this point, right? That means, if let's say, someone draw like that, is it correct? No. Someone draw like that, also not correct, because it cuts at 2. It must be exactly here and it touch at this point. Understand? It must be balanced out. But actually this is not very well done here. Understand? But I'm demonstrating to you, you got to adjust until it's possible and it's drawn properly. Everybody clear? Okay, good. Now, next I want to run through 2 questions that is on exercise 5B. Then after that I'm going to draw 1, 2, 3 graphs with it. Is that clear? Okay, now, then all of you look at number 5. All of you look at question 5 for me. Okay. The question says that, question 5 now. The sketch represents the graph of y equals to kAx when a is bigger than 0. Write down the value of k. This is a very easy question, but some people will still make mistakes. Just now I just talked about it, remember? When I started. So what do you think is the value of k? K is what? 3. Do you agree k is 3? Can you see? Can you write down k equals to 3? Exercise 5B. Write down in the book, yes. K is 3. Are we okay? Are we okay? Alright, then there's one that is not very difficult question. That is question number 9. Then all of you look at question number 9. I just want to teach you how to do that, that's all. Okay. Question number 9. I'm going to teach you how to do this. This is not the usual question. You understand? Okay. Using a, I'm only going to draw also. I just want to teach you the method. Do you follow? Okay. Using a suitable scale, draw the graph of 1 plus 1 over x for x between 0.5 and 3. Now, if you sketch, right, if I draw, right, the graph will actually go like that. Understand? Okay? The graph will actually go like that. Okay? Now, then they say, on the same axis, draw the line y equals to negative x. Now, negative y equals negative x is very easy. I want to have 2 points, right? When x is 0, y is 0. How about when x is 2? This will be negative 2, right? Correct? Okay? That means my line will be like that, right? Y equals to negative x, right? Alright. I want to ask you, is this correct? Okay, so the first 2 parts, no problem. It's the last part that I'm doing. This is not part 3. Can you look at part 3? Hence, find the coordinates of on the graph of y equals to 1 plus 1 over x, at which the gradient of the curve is negative 1. Now, can you see that this is y equals to 1 over x plus 1, right? Oh, they write it the other way. It's also okay now, it doesn't matter. I want to know how. Okay. Now, can you see this line here? I said it's not the usual one. And if I set this goes like the whole level line. You understand? Now, y equals to negative x. Can you tell me what's the gradient of this line? Negative 1, right? Do you agree that the gradient here is negative 1? Can you see it? What's the y-intercept? 0. Because mx plus c now. Okay? Now, do you agree that now the gradient of this line is negative 1? What did the question ask again? Read again. Find what? The coordinates of the graph of y equals 1 plus 1 over x, at which the gradient of the curve is negative 1. That means this is negative 1, right? I told you before, parallel lines have the same gradient. So I just need to until it touch, right? Correct. Then this one, the gradient will also be what? Negative 1. Then I find the coordinate of this point. Do you understand what I'm talking about? Now, can you see that this question number 9 is actually underway wrong? You don't want to find gradient. If you get the gradient, you want to find the point. Do you understand what I'm talking about here? Yes or no, class? I repeat that. Do you agree this guy, the gradient is negative 1? Yes or no? So, when I shift up parallel to it, I touch. This point will have gradient negative 1, right? Then you just find the coordinates of this point. Are you clear with what I'm saying? Can or not? Can, okay? So, I want to write down some notes for question 9. How about we write down some notes for question 9 so that you know how to solve the part here. You divide this into 2. That's why it's so easy. Why don't you divide into 10? Yeah, then you can cut 10 classmates out. But by the time he divide, right, most likely it become a paper already. Right, then you can throw already. Understand? Are we clear? Are we clear about question 9? Yes or no? Yes or no? Yes, okay, very good. Now, I am going to give you your HPL homework for tomorrow first. Because if not, you will not be captured on the YouTube. And those who are absent will not be able to do it. After that, I'm going to all it and I'm going to do the homework together with you. Are we clear? You're just going to plot, that's all. Then after that, Monday, we read, that's all. Everybody okay? Alright, now. Let's take a look at HPL homework. Very easy for tomorrow. You just read the textbook, page 139, and you flip page 139. Look at all the questions, all the work examples, until page 148. That's all. Is that okay? Can or not? There. But one thing that I want you to do, can you look at page 140? Can you see the thinking time there? I'm talking to the whole class. Okay? Can you see they describe some situation? Situation A, B, C, D, E, and F, right? I want you to match it to the correct graph. Can or not? Can or cannot? Okay, so I'll repeat that. Page PL will be, you read page 139 to 148, and after that, match the correct graph, the correct situation, the correct scenario on page 140. And we will discuss this on Monday. Are we clear? Yes or no? Okay, good. What number is on the content page now? Number is 17. Okay. Today's date. Gradient of a curve. Alright? I want you to take out 3 pieces of graph paper. I need 3 pieces. Okay? Alright. Can you write on the graph paper? Some people refuse to write anything, which is very bad. Exercise 5B. Gradient of a curve. And then today's date. Now, what questions am I going to do? I'm going to do 3, 7, That's all. 3, 7, and 8. Can or cannot? Can or cannot? Okay, now, listen carefully. I'm going to divide the board into 3. One for each question, after that you draw for me. Understand? After you finish drawing them, I can carry on with the questions. Is that understood? Okay, now, let's take a look at question 3. Okay, okay, good. Question 3, 7, and 8. Question 3. Now, I'm going to explain to you. If it doesn't need anything, then you just go do it yourself. Everybody okay? Can you all look at question 3? Hello? The table below shows some values of x and the corresponding values of y, correct to one decimal place, where y is 2 plus 2x. Find the value of a and of b. Then using 4 cm to represent 1 unit of x axis, so and so forth. And then, can you see there's part 2 and part 3? Now, this question is exactly the same as example number 5. Is that understood? So I'm not going to go through it, you're going to do it yourself. Understand? Got question and Monday we go through it. Follow? Now, next. Question 7. Using a scale of 2 cm to represent 1 unit on the x-axis and 2 cm to represent 5 units on the y-axis, draw the graph of this. Okay, this is what you do. This is one graph paper. This is another graph paper right at the back. The question says from negative 2 to what? Negative 2 to 5. Okay. So, what should I be writing there? Very good. I should be writing negative 2, negative 1, 0, 1, 2, 3, 4, and 5. You fill in the blanks. Is that clear? Now, if the question gives you the scale, yes, okay. So they gave you x-axis 2 cm to 1 unit and y-axis 2 cm to 5 units. Understand? So this will be a question 7. Everybody clear? Okay? Now, don't worry, I'm not going to think about it. Can you listen to me first? Can you look at 7 part 2? Find the gradient of the curve when x is 4. That means you must draw a tangent. Do you understand? Then, next part 3. Find the gradient of the curve at the point where the curve cuts the y-axis. Understand? Okay, there's another tangent. Do you understand? Okay? Now, next we look at question number 8. Okay? Next we look at question number 8. Are you all okay with the HPL? Get out. Question number 8. Using a scale of, I want to change the scale because this question is a bit strange. Okay. I use the scale of, okay. Alright. I'm going to use the scale, you write this one. Okay. Then we are going to give the table. They say from negative 2 more points. Okay, now I want to ask a question. Will it have a value at 0? It will not have a value at 0 because of this guy, right? So this one you cross out is not a distance. You understand? Alright. That is what is an asymptote. Which one? The y-axis, right? Will be the asymptote. Can you all see? Yes or no? Okay, I'm talking to you. Yes, I cannot cut the y-axis. Can you see? Do you understand what I'm talking about? Yes, okay, good. Then you just draw, and then you answer the questions. Okay? Alright, I'm going to off the video, and I'm going to help you now, okay? Because this one is I want for you. What's the scale? I'll give you the scale. Oh, I haven't write down the scale. Oh my god. I want to change the scale, sorry. Thank you for reminding me. I want you to change to this scale. I want you to change to 2 cm to 1 minute for the y-axis. Okay? This one you just follow the scale given in the question. Alright? Can or cannot? Can or cannot? Can, huh? Okay, so I'm going to off